Guided exercise number 1 says let f of x equal negative x squared plus 4x, and let g of x equal x. On the interval 0, 3, consider a Riemann sum with 3 subintervals and write endpoints. Sketch. So on the leftmost graph, the rectangle is corresponding to the Riemann sum for f. So we're supposed to have 3 subintervals and write endpoints. So I'm going to go ahead and write this up here. This means that delta x is 1. We've got 0, 1, 1, 2, and 2, 3. So we should be using 1, 2, and 3 because those are our right endpoints. So on the leftmost graph, the rectangle is corresponding to the Riemann sum for f. By the way, that is the graph of f right there. Okay, so we're using right endpoints. So I'll mark my first right endpoint, go up to my graph, go up till I hit my graph, and then make my rectangle. Second subinterval, there's my right endpoint, go up till I hit my graph, make my rectangle, and then same thing for the third one. The second bullet point says on the middle graph, sketch the rectangles corresponding to the Riemann sum for G. Okay, still using 3 subintervals right endpoints. So mark my first right endpoint, make my rectangle, mark my second endpoint and make a rectangle, mark my third endpoint and make a rectangle. And on the right graph, the rectangles remaining when those in the Riemann sum for G are subtracted from the ones in the Riemann sum for F. So the question is, what's left? Well, from 0 to 1, I have this much area left when I subtract blue minus red. And then on that second subinterval, I have these top 2 squares of area left. And then on my third subinterval, I have nothing left. So this is what I get when I subtract. So when I take the Riemann sum for F and subtract the Riemann sum for G, what I'm left with in my picture is these 4 units of green area. So underneath the picture, the problem says set up a definite integral representing the total area between y equals f of x and y equals g of x on 0 to 3. So let's think about the Riemann sums. The green picture, the rightmost picture, is a visualization of a Riemann sum for F minus a Riemann sum for G. And it very much looks like this Riemann sum for F minus Riemann sum for G is a good estimate of the area between the curves. This estimates area between the curves F and G. And so the Riemann sum is giving us an estimate. So if we want to do the exact area between the curves, at least in this example where everything is staying above the x-axis, so since f is greater than or equal to 0 and g is greater than or equal to 0, at least in terms of our visual making sense here, the exact area is area under f minus area under G. And by area there, I do also mean exact area. And so the total area between the curves y equals f of x and y equals g of x is the same thing as the definite integral from 0 to 3 of f of x dx minus the definite integral from 0 to 3 of g of x dx, which is the same thing as the definite integral from 0 to 3 of f of x minus g of x dx. So in this picture here, we've made some very specific assumptions about the nature of our functions, namely that their graph stays above or on the x-axis. But more generally, anytime you want to find the total area between two curves, you always want to do the definite integral of top function minus bottom function. And so this does always work out.